Let's look at completing the square, which is a method to work out the coordinates of the turning point of a quadratic. So the example says, find the coordinates of the turning point of y equals x squared plus 4x plus 3. Now the way we complete the square is we look at the first two terms of the quadratic, which are x squared and 4x in this example, and then we try and factorize this into a squared bracket. We write in two brackets and we include the square, and then we take the variable in the quadratic, which is x, and we place that in front, and we look at the term that has a single x in it, which in this case is 4x, and we halve the coefficient. So the coefficient at the moment is positive 4, so halving that gives us positive 2, and we place that inside the bracket. Now if we were to expand x plus 2 all squared, we would get the following. So x times x, which gives us x squared, x times 2, which gives us 2x, and then 2 times x, which gives us 2x, and then 2 times 2, which gives us 4. And so collecting like terms, we end up with x squared plus 4x plus 4. Comparing x squared plus 4x plus 4 with what we completed the square on, which is x squared plus 4x, we see that we have an additional 4 here. And so because x plus 2 all squared expands to give us x squared plus 4x plus 4, we need to now subtract 4 so that we're left with x squared plus 4x. And since we haven't done anything to the plus 3, we can now add that on at the end. And so simplifying this, we end up with y equals x plus 2 all squared, and then minus 4 plus 3, which gives us minus 1. And so we have now completed the square on x squared plus 4x plus 3 by writing it as an expression with the squared bracket. The question, however, is to find the coordinates of the turning point. And so let's sketch the graph of this quadratic to help us with that. If we factorize the quadratic, we have two numbers that multiply to make 3 and add to make 4, which in this case are 3 and 1. And so factorizing this quadratic gives us x plus 3 in brackets and x plus 1 in brackets. Therefore, the roots of the quadratic are x equals minus 3 and x equals minus 1. And so sketching our quadratic, we have two roots at minus 1 and at minus 3, and we know that the y-intercept of the quadratic is positive 3. And since the coefficient of x squared is positive, is a u-shape. So sketching the quadratic, we should get something that looks like this, with the y-intercept being positive 3. Now looking at the sketch, the turning point of this quadratic is where the graph goes from decreasing to increasing. And so we can see that that turning point is this point at the bottom here, which in other terms we can call the minimum point. Now because this turning point is the minimum of this quadratic, we're looking to find the smallest possible y value that we can obtain for this quadratic. And so we're going to use the completed the square version of the quadratic to help us with that. Now to obtain the smallest possible value of y so that we get the y coordinate of the turning point of this quadratic, we need to consider the square here. And so we're looking at the smallest possible number we can obtain after we square something. And that smallest possible answer is 0, because 0 squared is equal to 0, and any other number that we square, whether it's bigger or smaller than 0, will always end up being positive. So for example, 1 squared is equal to 1, which is bigger than 0, or minus 1 all squared is equal to 1, which is bigger than 0. Or say if we had 0.5 all squared, we end up with 0.25, and so on. So because we've just seen that 0 squared is equal to 0, which makes this as small as possible, then we need to make the bracket here equal to 0, and then solve. So x plus 2 equals to 0, and then solving this gives us x equals minus 2. So when x is equal to minus 2, this bracket, when we square it, then equals to 0. And this is the x coordinate of the turning point that we have here. So we label that on the graph. Now to work out the y coordinate of the turning point, we just need to substitute this x value into our quadratic. So we have y equals, instead of writing x now, we're going to write minus 2, and then we have plus 2 all squared minus 1. And so because minus 2 plus 2 is 0, and 0 squared is equal to 0, then we end up with 0 minus 1, and so the y coordinate of the turning point is equal to minus 1. Looking that on our sketch, we have minus 1 down here. Finally, we can then say that the turning point is the following coordinates which we worked out, which are minus 2 and minus 1. two more questions to help us further our understanding. So the question is to find the coordinates of the turning points for the following quadratics. So the first quadratic is y equals x squared minus 6x plus 2. And so we're going to use the method in the example to then find the coordinates of the turning point. So we'll first look at the first two terms of this quadratic, which are x squared minus 6x. And so we begin by writing this as a squared bracket. And so we have x as the variable, so we'll write that in front, and we halve the coefficient of the single x term, which in this case is minus 6. And so halving minus 6 gives us minus 3, so write that inside the brackets. And now if we were to expand this bracket out, so we have x minus 3 times x minus 3, then we see that we end up with the following: x times x, which is x squared, x times minus 3, which is minus 3x, minus 3 times x, which is minus 3x, and then minus 3 times minus 3, which is plus 9. And so collecting like terms, we end up with x squared minus 6x plus 9. And because the plus 9 is extra to what we have here, we need to subtract that. So we take away 9 and then add the 2 on the bottom. So simplifying this further, we end up with y equals x minus 3 all squared, and then minus 9 plus 2, which is minus 7. And so if we want to work out the coordinates of the turning point, we make the bracket equal to 0, so that's x minus 3 equals to 0, and then solve for x. So solving for x gives us x equals positive 3. And then to work out the y coordinate, we can just look at the number on the outside of the bracket, and so that's minus 7. So we finally have that the turning point's coordinates 3 and minus 7. The second question is y equals x squared plus 3x minus 7. So again, to complete the square, we'll look at the first two terms of this quadratic, which are x squared and 3x. And so we write in a squared bracket, and inside the squared bracket, we write in a single variable, which in this case is x at the front, and then we halve the coefficient of the single term that has x in it, which in this case is plus 3x. And so the coefficient is 3, halving that gives us plus 3 over 2. And now if we were to expand this bracket out, so we'll do that on the side here, x plus 3 over 2 times x plus 3 over 2, we would end up with the following. So x times x, which gives us x squared, x times 3 over 2, which gives us 3 over 2x, and then 3 over 2 times x, which is 3 over 2x, and 3 over 2 times 3 over 2, which is 9 over 4. And so collecting like terms, we end up with x squared, 3 over 2x plus 3 over 2x is 6 over 2x, which simplifies to 3x, and then plus 9 over 4 on the end. And so we see that the extra term here that we have in comparison to x squared plus 3x is the 9 over 4. So taking that away and then dropping down the minus 7, we then simplify this further to give us x plus 3 over 2 all squared, and then minus 9 over 4 and minus 7, so minus 7 can be written as minus 28 over 4. Now taking these two terms away, we end up with y equals x plus 3 over 2 all squared, and then we have minus 9 minus 28, which is minus 37 over 4. And so finally, to work out the coordinates of the turning point, again, to work out the x coordinate, we make the bracket equal to 0. So we have x plus 3 over 2 equals to 0. And then solving for x, we get x equals minus 3 over 2. And then to work out the y coordinate, we can either substitute this x into the quadratic here, or we can just look at the number on the outside, which is minus 37 over 4. So the y coordinate of the turning point is minus 37 over 4. And so finally, as coordinates, we have minus 3 over 2 and minus 37 over 4.